Here we import NumPy, which is a library function for numerical operations in Python. Specifically, we are going to use it for array manipulations and computation of first Fourier transform. Next, we are going to define input array. So x1 and x2 are two input arrays which represents two different time domain signals. In this case, they are discrete sequence of length 6. These arrays will be transformed into frequency domain using the FFT in the next step. Next, we are going to define constants a and b. A and b are scalar constants. They will be used to linearly combine the signals x1 and x2. Now we are going to compute the FFT of each signal. So this x1 is the Fourier transform of this signal, and this x2 is the Fourier transform of this signal. Next, we are going to verify the linearity property. The LHS represents the FFT applied to the linear combination of the signals x1 and x2, and the RHS represents the linear combination of individual signal FFTs of x1 and x2. We first compute the FFT of x1 and x2 separately. Here we already computed the FFT of x1 and x2 and then scale them by A and B respectively. Now we are going to compare these two results. So np.allClose checks if the elements of LHS and RHS are almost equal. If the elements of LHS and RHS are equal or close enough, it means the linearity property holds, otherwise it doesn't. So then we have to print our LHS and RHS. We are going to run this code. See, your linearity property holds.